Thank you. So, hello everyone. So probably you have seen this kind of figures all the time, where you see a lot of things going on, and actually, sometimes you don't really know how to use them. And we have seen, for example, yesterday that people they do heater. Heater has all these kind of things inside. They do heater in a box. So basically, everything is hidden. You have a lot of different technologies, and today Mohamed and me, Damien, we will make step by steps a setup. So you will do it yourself on hands-on. So normally you have installed some environment for deploying it, and we will try to deploy such the network by ourselves. But instead of having a black box that you just click and it works like just by magic, we'll see every single step to understand why they are there, such that actually when you will want to deploy your own test bed, so in our case, this is what we use in the test bed in the Sophia node, a test bed in Inria and Recom. But then the day you will want to deploy your own test bed with real hardware, you will see what is needed. I'm not saying you replicate exactly what we'll do today there, but at least you will understand every single step. Can you just confirm on the Zoom that you can hear perfectly well? They said yes. Okay, great. So step by steps, what we'll do today is we will set up the R2 Lab environment, the Sophia node environment, and actually just the network part. Basically, the network part is composed, the programmable network part is composed of 3 programmable switches that are running Tofino ASICs. So Tofino ASICs are used for being able to program the data plane of the switch directly, not only the control plane, that are connected together to different switches. And when you want to do this, it's to be able to run, for example, ITER on the system. Run ITER on the system, you need a lot of different components. First thing, of course, on every single device, you will need an operating system. In this case, for example, on the switches, we will use Open Network Linux, which is basically a Debian distribution that has been a little bit tuned for being able to use the programmable switches. Also on the servers in the real environment, what we have here, our clusters are running Fedora Linux. So already here we see a problem. We have 2 different distributions of Linux. The first problem comes here, but we'll see it's not the only one. Once you have the operating system, you cannot do much. And as I said, we have programmable switches using P4. So it means that they have different ASICs that you can that I cannot show you. Anyway, so you have ASICs, and those ASICs can be programmed using P4. Oh, that's okay. Because anyway, online they don't. And interestingly, actually, here we have 2 different types of switches. The one on the bottom that are supposed to run a lot of functions are, in our case, they are H-core wedge 100DF32 QS. And the one that interconnects those switches is a 100DF32X. There's only 2 letters of difference, but that changes the ASIC inside. So it's not exactly the same thing on both of them, even though they are very similar. Okay, so you have this. But to run P4, what do you need? With P4, it's a language that allows you to program your own data plane. But for example, now you need to implement a data plane. Let's take here the example of using SD Fabric. SD Fabric, you have seen, I think it was yesterday or the day before, I don't remember. But that's basically switch implementation with some features for 5G and beyond. That is proposed by the ONF. And so you have the full pipeline, and the good point is that you can run, for example, the UPF functions directly inside the switches. So not especially on the servers, which can be useful if you want to speed up. So you don't need to go from one place to the switch, then switch to the cluster, then the cluster back to the switch, and so it can be processed directly within the network. So when latency comes into the game, that's really useful. Okay, so you have those SD Fabric, but of course, SD Fabric, we want to be cloud native. So we will put some, oh, we'll put some container solution. Let's make it simple. On the switch, we will put Docker, but on the servers, we'll put Cryo. Just to make it easy, because in real life, things are like this. People like to use some other things than others. So we are here in a heterogeneous environment. Okay, so now we are able to be kind of cloud native. That's nice. You have the possibility to deploy containers on the switches or on the servers, but you have to manage them. So what do you do to manage them? You will put something like Kubernetes. Kubernetes will be used. You could use other solution, of course, but Kubernetes will be used to orchestrate the different containers. So if something gets wrong, it can be deployed on another machine. For example, you lose one server, it goes to another server. Or to decide, okay, this is a function to be used on the switch to make sure that the container is deployed on the switch, not on the server. Okay. But once you have there, it's not finished yet. You will manage all this with a controller. Let's say we are in an SDN environment, so let's use a controller. A controller is what? It's kind of a server that can be distributed, that will be the actual brain of the system, and that will program all the devices that you have. For example, it will put the P4, let's say the P4 code, it's not exactly true, the P4 code on the switches, or it will set up the links, it will discover the host, it will make sure that everybody knows the topology, this kind of thing. Once you have that, it's not finished yet, because you have an OS on one side, which is the brain. You have P4, which is doing the dirty part. But then you need to interconnect and to make sure that the controller can discuss with the switch, and the switch be programmed and send back information to the controller. So we add on top of this Stratum. They like to call it an operating system. That's funny because if you look on ONF, you have ONL, which is an operating system, it's a Linux. You have ONOS, which is also called an operating system, a network operating system, and Stratum, that is again an operating system. So basically, let's see it as different layers. You have the lower levels on the hardware with ONL, basically Linux, then the highest level ONOS, and then the kind of middleware in between, which will be Stratum. So normally, if I touch this, there is no step anymore. Yeah, the step now is to do it, actually do it. So I invite you, the one that wants to do the hands-on, to go on this GitHub. So github.com/sopnode, SOPNODE, sopnodes for Sophia node. And then in there, you will see different repositories, and you can go to the Slices SC Summer School repository. Who will actually do the hands-on on their machine? Yeah. Oh, one, okay. So we are two, great, don't be shy. You will manage to. So one per table. I will need someone in this table and you are alone in the table. Yeah. So did you manage to set up the environment already that we sent yesterday? You have, so now I will switch to the, and on the attendees online, is anywhere going, does anyone working on it or not? Okay. So in this hands-on, what we do is, as I said, we will run this. Actually, we will not really do it on the physical infrastructure, because the physical infrastructure, only one person at a time can do it, because it's physical, it cannot be multiplied. So, instead, what we propose you is to have a sandbox, the one that we sent you yesterday. So basically, the sandbox is what? We prepared image in virtual boxes, but before coming here, we were using it directly in Google Cloud. Doesn't matter. Where every single switch that I showed you before in the figure is actually a virtual machine running a Linux plus the switch. The switch is of course not the edge core, so there is no ASIC. So instead, we use the BMV2 switch. BMV2 is basically a software switch that is programmable through P4. And that's the only difference with the physical infrastructure. We don't use Mininet. The reason is that actually we will run Kubernetes, we will run a lot of things on them. So we really make that it appears like a true appliance. So if at some point you want to extend the setup that you have here and say, I want to have, for example, 2 emulated nodes and 1 physical switch, you can do it. You will interconnect it. It's just a matter of putting the interface and making the link. If you want to do these things later on, like in 1 week or 1 month or 1 year, just ask us and we will show you how to do it if you don't manage to do this kind of thing. Okay, for the 2 doing the things, no one else wants to do the hands-on. Don't be shy. Anyway, at some point when you will create the test bed, you will have to do this kind of things. It has to be done at some point. So for the 2, do you have the 4 boxes running? No. And you from Leipzig, you have background and VirtualBox working? Not yet. Okay. Now, so if you have problem with the addresses, you can. It's because you are using VBoxNet 0 probably that is already configured with some prefix, not the same as us. So either you change on your VirtualBox config, or you change in the Vagrant file. The best is to change the VBoxNet 0 from your setup. Okay. And in the meanwhile, so while you do it on the emulated environment, I will do it on the real infrastructure. So we'll see on the real infrastructure, it will really become quick. So here I'm connected to an infrastructure, and to show you that I'm not lying, I will show that there is no cube, for example, no Kubernetes. So here we are really, as you can see, you see nothing, that's normal. So here I made a watch that shows, please show me the nodes that are in Kubernetes. And actually you see that there is no cluster yet. So as soon as the setup will be done for the 2 people, then we will follow step by step. So the first step will be to create a Kubernetes cluster. Then when you do it, we will explain what are the different steps that are needed. And then after, it will be to add the nodes in the cluster. And once the Kubernetes cluster will be done, then we'll be able to do the rest. You raise your hand when it's done. We have another team. Oh, good, good. Yeah, that's okay. Yeah, yeah. Yeah, so when they are running, when they are up, just wait, and we will follow the different things. And okay, so I saw virtual machine running, so that's kind of good. So per table we have something, so it's good. Okay, we will still wait a few minutes for the setup to be done on all the machines. So on the 4 box that you have, 3 are used for the switches, and 1 is actually called Ansible controller. And this is a machine where we already pre-install Ansible and the different modules of the Galaxy. So because here the network is a bit slow, so to avoid you to download, we are already installed everything on them. So actually, if you have the image, we can go to the next step. So normally, so you have done all of this, and you end up having the 4. Oh, there's something in front of the screen here. Okay, and so you go to an Ansible controller, back to the main. Another point is that we made the playbooks that we are using in our environment. We make them available also for the others. And because every time we want to do something in a Sophia node, we first want to try it on a virtual environment before breaking down the actual infrastructure. So it's a continuous integration and continuous development. And so we run our scripts in the virtual environment first. And this is by using BMV2, and this is what provided you as well. So all the playbooks that we have to deploy Kubernetes, to deploy Stratum, to deploy SD Fabric, ONOS, and so on and so forth, they are compatible with either actual physical infrastructure using Tofino switches or with BMV2 switches. You will understand later if you haven't. Did anyone already coded in P4 here? Who made some P4 code? No? So most of the time you will see when you will, because ultimately we will do P4 code to implement 5G functions of our own in the environment. So all the tutorials that you see, they are always done on the BMV2. BMV2 is the software switch that they provide. It's basically to do simulations. So this works pretty well, but actually when you compile it for this particular target. If you compile it, if you want to compile it on a Tofino switch, so with the ASIC, you have to compile differently. It's like if you have some C code that you want to run on an ARM or a x86 or a M1, you have to recompile it because it's not the same target machine. So when it comes to compiling for Tofino switches, you cannot use the P4C, which is the standard P4 compiler, but you need to use P4 Studio that is coming from Intel. So that allows you to compile for Intel targets, which is Tofino. So for information, before being Intel, it was Barefoot. So probably you heard of Barefoot, and then it went to Intel. They got bought by Intel. So, and this is why we need to have different steps, because the way you compile is not the same because you have licensing issues. So everything is fully open source, for example, for the BMV2. But if you want to go for the Tofino, then it's closed source. So you cannot have the compiler like this, and you cannot have access to different information. So you need to go to Intel, ask them authorization, get license, and all of this. So this is why we have different steps. Okay, so for that now, normally, if you follow the instructions, you are in the directory on your host, and you should be in the directory of the Ansible controller. Is it the case? Oh, you can be directly in the Ansible controller in your host if you want. That works as well. So in this, you just clone the fabric.git repository. This is where we store everything, or we will have all the playbooks. So in the Ansible, on the Ansible machine, you can just clone this Git. You have them? Yeah. So you are cloning it, or so you do the Git. Yeah, but we'll go to there. Actually, if you follow the instructions, then yeah, yeah. But if you do a Vagrant SSH from your host, you should connect if you are in which directory. So you do Vagrant SSH and Vagrant SSH with a T, and it will be a bit slow, but it will connect. Yeah. So yeah, that's okay. You can do it directly from the machine, and the username is Vagrant, and the login and the password is Vagrant, if you want. Actually, if your machine does have like less than 6 or 7 gigs of memory available and doesn't have 6 or 7 cores, that can be very slow. But that should be it. So you are there. You can, okay, so you can clone. Did you clone everything already? Ah, yeah. Okay. Yeah. Yes. So here you go in your virtual box, and you can change so you can start your virtual box. No, no, specific directory, specific background, like 192, that's 128, that's 54, but it should be, so you have a bigger screen. IP space KG here, IP space KGB. IT space with new command for item. What is your best? Now the other one, another one is the modify the four variant time. Because the machine is slow, you can jumpstart the simulation and run it. When the variant size of 6.60 on the controller, instead of 6.50, then you do variant size controller. Okay, so we are still doing the setup for the virtual machine, so I will jump. Okay. Okay, as there are some troubles with the machine and the setup not being ready yet, we'll change something. So now people doing the hands-on actually, Mohammed will pass through you and explain the thing. So you will have a personal professor just for you, like this. And for the others, I will actually do on the screen the deployment on the actual infrastructure and explain what happens so that you are not just waiting like this. So we change a little bit. But you will see the one doing the hands-on, eventually you will have it working, so that will be great. And for the others, so I will explain progressively what I would have explained to you. Okay, so let's move to that now. So as I told you, the first thing we need to do is to install Kubernetes because we want to be able to deploy the different containers. So to install Kubernetes, there are two major steps to do in a basic environment. Let's not get too complicated things. For example, in a Sophia node, we have two different infrastructures with different subnets, so it's much more complicated than what I will show today. But here is we'll just create one Kubernetes cluster. The first thing, the first main task you have to do is to create a master somewhere. So it will be the brain of the Kubernetes cluster. This is the one that will initiate everything, that will create certificates, and that will be used to have the different demands that will control everything. In this environment, we will use only one master, but in typical environments, you will have several ones, such that if one breaks down, you can use another one. So as I show you, for the moment, there is nothing on the switch. So here we are connected directly on one switch in the controller, and we ask to see the Kubernetes cluster. As there is no Kubernetes cluster, it makes an error. So let me go to this. And don't worry. So the first thing I'll do is in the, it's really small. I just started. So basically, we create a first playbook. So a playbook, Ansible is a tool that is pretty handy. This is why we use it. It's basically doesn't require you to install anything on the target hosts. You just need to have a way to log in to it. So basically SSH. And that allows to push configuration of files or modify things. And so here I just launch a playbook to it, and I will explain. So he will do his stuff. It's not really important to read what does the playbook exactly, but now let me show you the playbook here in big and explain the main steps, because that's what that's interesting. And if you want the actual details, of course, you go. Okay. So, and in the tasks, I'm there. So what we do, first thing is, can you read, or should I make it a bit bigger? So the first thing we do is we say, okay, we'll create a new cluster. This new cluster, one thing that is really important when you run Kubernetes, it's that within your cluster, it's assumed that all the containers can directly connect to each other. So basically, they all share the same LAN, or the same subnet, sorry. So you define a subnet. When you get to have different subnets, then you need to add specific things. But the initial assumption is that you can connect directly at the layer 3. So it's not a layer 2 communication, it's layer 3. The point is, by doing so, it means that you can put your pod, what is called a pod, so a container, in different places, or a different replicates of the same pod in different places. So that's really important. And so this is what you say here. You specify and say, I want them to be all in one specific cluster. Plus, as you notice now, the idea when you use Kubernetes is that you will deploy containers that comes from images. And when it comes to images, you have to get some form of authentication. So you will generate also certificates. So when you initiate your Kubernetes cluster, it will also create a certificate of authority. And the point is that So everything that you will do, all the authentication that you will perform within your Kubernetes cluster will rely on this certificate of authority. You will generate tokens because, of course, you don't want that a simple user be able to destroy your Kubernetes cluster. That would be an issue, particularly for us, because we want to provide access to the people in the test bed, but we don't want them to break the test bed, but they have to be able to do so. Okay. And so this is why it's really essential. And if you don't do that, you will usually break when you have multiple hosts. You have also to say, okay, upload the certificates to publish the certificates in the cluster as well, such that the other people will be able to get the certificate of authority. Once you have that, actually you have two different cases, and that's a bug that is coming really, not a bug, but that's an issue that is coming frequently, is that either you are lucky and by default everything works, or you are not lucky and by default it will take an address, so you will decide to advertise the service on an IP address, but it takes one among all the IP addresses that you have on your servers. So sometimes you have to force the IP address by it. So you might have this issue, and this is what we deal here with. Because basically what it does, it takes the default address of the machine. What is the default address of a machine? Is the IP address of the interface that is linked to the default route in your system. Most of the time, this is not the one to use to manage your Kubernetes cluster. Will be typically this will be the interface that is connected to the internet of your cluster. So that's not exactly the one that you want. So this is an issue that comes really frequently when you do Kubernetes cluster in real environment, like with multiple interfaces connected to private networks and to public networks and so on. So that's something. It's not really important to see the command, but then by having this hint, you will know if ever you have the problem, you will immediately understand why it's not working. You will remember, it told us that it's because of the. So that's really the point today. It's not to learn the command, but it's to know the different pitfalls that you could have to deploy SD Fabric. So once you are done with all of this, you have some stuff to do. So for example, you have to prepare a network. Because by default, you use a very basic system of network, Kubernetes, but in SD Fabric, it's recommended to use Calico. Calico is kind of network environment. So it's a way to prepare your network environment such that if you have, for example, you can do LANs or VXLANs and all of that. So if you have clusters that are spread among different machines and maybe not on the same subnets, that will do all the tunnels for you, and that will manage the signaling of the different protocols needed, routing protocols and all of that. Behind this, there is BGP. It's hidden for you, but we deploy this, and this is recommended for SD Fabric to use this one. Again, when you get to complex environment, then it will be handy to have Calico, because in this case, you will be able to specify policies or these kind of things, access or translation of addresses. So this is basically what is done. So normally now it should be deployed. We'll see, okay, look, we are happy. Because if you remember in this command before, we had no node, and now we see one node. And it's actually the control plane and the master. That's what we wanted on one machine. So once we have this, it means that we are ready to have any machine we want on this cluster. So if you want to add 20 machines of your Kubernetes cluster, it's fine. But what you need to do is, of course, I told you you have some credentials needed, some authentication needed to be able to add them. So this is what we will do on all the other machines on the cluster, in this case, the two other switches. We'll deploy them. So let's take on the other playbook. In this case, it's Kubernetes node. And let's try to understand what it does. Actually, it's really simple what it does. I deploy them, and eventually we will see. Okay. So, and you see there is a little trick that you have to do. It's here. Okay. So to be able, so how does work Ansible? Normally, you have a playbook and you specify a list of hosts on which you want to run the task, and it's run in parallel. So if you want to run the playbook, for example, install Kubernetes on switch 2 and switch 3, for example, or switch 1 and switch 3, then it runs on there. But the issue is first we need to retrieve from the cluster, we have to, from the master, we first have to create a token for authentication. So first what we do here in the playbook is we will connect to the master and basically we will get the configuration. So when you initiate the Kubernetes cluster, it will generate you a configuration file where you have all the IP address that has to be used, the API, the URL for the different APIs, because everything is based on REST APIs. So it's everything in this file that is stored in the master node. So you get them, we copy them locally such that we will be able to push them on the different machines so that they know the configuration they need to use to connect to this particular cluster. And also we generate a token on the master token that we create. Here we say we leave only for 15 minutes. You will see some environments, people leave them forever. It's not needed. Usually tokens try to keep them always only the time you need, not more, or then clean them after. Here I decided because I will not clean them, at least they will disappear, because if something breaks, I want to disappear eventually. So once you have this token, we get it back, and then we can launch the deployment of the nodes. Let me get to them. And the deployments of the nodes, you will see that it's then once the cluster is created, it's really simple. Basically, you get back the configuration, and here you specify the token to be used for authentication. So when you generate the token, of course, you take a token for authentication to be able to add it, because you can put different access level of access. Of course. Here we don't have yet the certificate of authority. If you remember, I told you, okay, we have to create, because we do authentication and all of that, we have to create certificates. Here they are not yet on the node, so we ignore. If you don't do that, you will have errors. So for example, if you do a CURL on the machine, you will say, oh, beware, the machine is not correct. You have a wrong certificate of authority. So this is normal because we haven't yet it yet. And you specify on the node. And now it's also time to get these certificates. And so we have, this is of course very simple. You get back the certificates, copy them locally, and you have to put them, so you put them, so you know on every operating system, there is a place somewhere where you keep all the certificate of authority. And for example, remember that last year you have a lot of troubles because one main one was expired. And so a lot of websites were said to be unavailable because unsafe. It's not that they were unsafe, just that the certificate authority was wrong. And so you had to update with the certificate. This is exactly what we do here. But once you do that, you have to inform Docker, because we run Docker, to get this new certificate as well. So you have to restart Docker. So this is an error that comes frequently, that you will have, you say, okay, I did it, but actually you will see the authoritative certificate in your list of certificates, but Docker hasn't been restarted. So it will say the image cannot be authenticated, so you cannot get there, you cannot retrieve. So don't forget to restart Docker. So once all of that is done, normally, if we go to the switch, we should see 3 nodes. Amazing, we see them. Now there are 3. They are ready, so we are happy. And you see that they are just normal nodes. There is nothing special, there are no master or whatever. So now, with those different steps that you can learn in detail, because actually you will see we have dependencies, we have to install a lot of things on the operating system. You have to disable, to set the huge pages, you have to disable the swap, all of these kind of things that are little details, but that are needed if you want your cluster to work correctly. But at least this is done. And assuming you have a good internet connection, this takes about 6 to 7 minutes, 10 minutes at most to have this environment, even if you have 10 nodes, 20 nodes, whatever. So it's really fast to do. So the good point is that in testbed, so why we do that using Ansible? Because the objective is here in the testbed, we offer it to the people, and every time they do anything they want on it, and then we restart the testbed from 0. We put back the firmware to good TP, so that it's again a completely white box environment that people can repush everything. So this is important to find a way that is completely automatic for that and fast. So every time you do an experiment, the good point is you will be able to replicate. If someone did another experiment before, you will not be impacted. Okay. So now, any questions so far? Maybe you are already acquainted with Kubernetes and I just made you lose your time. I don't know. Who already deployed Kubernetes in somewhere else than on his machine, on his laptop? Good. And you had the same kind of issues or? Same kind, yeah. Or was it smooth and it was smooth for you? Well, so then I make you lose your time by explaining this. So now at least we have an environment that is ready for what we want to do. And we start the interesting things. So the point is, normally, you will see, yeah, but Kubernetes on the switches, you should ask me the question, but that's weird. You make your switches being part of Kubernetes, but they're not compute nodes. And of course, they are not compute nodes. So now what we have to say is to inform Kubernetes that the nodes that the switches are, we should inform that they are switches, not normal compute nodes. But still, we want them to be in the Kubernetes cluster. Why? It's because actually, ITER or this kind of tools, they potentially use Kubernetes to deploy the different functions on the switches. So what you want is to say, now to inform them that, okay, the switch are switches, the computer compute. And so for that, you have to put label sentence on this. So for example, you say no schedule. So you are sure that the switches by default, they will not be used as compute resources. So when Kubernetes tries to schedule a normal container, a normal pod, it will not put it on the switch, but on your cluster of compute machines. And you put a label with a specific name that is provided depending on the solution that you use that defines what that is a switch. So it's basically you put a tag on the machine. So this is what we do now. Okay, we will not do it here because we only have switches, so it doesn't matter. We don't do compute stuff. Okay, but this is something that you have to do. But beware that in this case, once they are put like this, they are not. You will not be able to deploy normal pods on them. So if you have only 3 switches, don't do that because then you will not be able to deploy on us because on us will be deployed on a compute, but there is no compute because of it. Okay, so now the interesting part comes, and because we have a full network working, Kubernetes, we can start to deploy. And for example, here we will deploy Fabric, SD Fabric. So SD Fabric, you have different steps. First, you have a P4 program that encodes the data plane. In this case, we will use the switch, not the UPF, but for the demo, we don't use UPF. But in practice, we will do your UPF or your own P4 code. So you have this code, you have to compile it. Once it's compiled, I will start it and explain why it's doing the job. Voilà, I started it. Let me go to the deployment. So basically, what you will do is you take your P4 and you have to run it in your P4 controller. If you are using BMV2, you can use directly P4C that is available from the p4.org. You take your P4, you compile. If ever you are using to the Tofino, which is the case that we want, the problem is you have first to create a container with P4 Studio. This is how the script is working. Of course, you can modify the script, but by default, this is what they do. So you first have to register to Intel. So if I remember, nobody ever had made some P4 code for Tofino in the room, right? So I will explain you a bit the procedure because it takes some time, and now people from Ericom also tried it and they can confirm that it takes some time. It's not a technical problem, it's an administrative problem. And for the slices project, it's an issue so far. Unfortunately, we don't have people from Intel here. So what happens is first you have to register as an academic in the academic program of Intel. You will have an NDA, you say that, okay, if you want to do publication, you provide them what to do, they read and they give you approvals after 10 days. Once you have done all of this, then usually it takes a few days with the administrative people from Intel. They will give you a kind of an authorization to add users to the Intel group that you made. And once you have that, you can add people to the group and they will have access to the forum of Intel, the private forum of Intel. And this is only when they have access to this that you can download the SDE. So it's the development environment of Intel for P4 and the tool P4 Studio. You will receive this SDE. You can download it. And once you have downloaded it, you will have to compile it and to make a container out of it, because the process to compile P4 code from Tofino is actually by going through Docker. So it assumes that you have a container running, an image available with P4 Studio in it. So you create this from the SDE, and actually there is no documentation about it. So you can read how we did it. I don't know if it's the best way to do it, but that's the way that works at least. They just say, okay, we assume that you have a container with P4 Studio. So they give the information about how to create P4 Studio, how to compile it. How long did it take finally for you? It didn't compile. Yeah, for me, the first time I did it, it took 60 gigs of storage to compile P4 Studio. Everything is closed source, so we don't really know. And several hours, but now I managed to do it in, let's say, during the lunchtime, it managed to compile. But at least, so once it's compiled, then you push it in an image, and then you can start. It is really important here, and that you have, when you decide to compile, and when you decide to push the things, you have to know exactly which SDE you use. Because if it has been compiled with 9.6 or 9.7, I mean, it might be different. At least it doesn't work. I don't know what changed because I don't have access to the source code, but it changed something. So you have to really be sure that every step that you do in SD Fabric, you are doing it with the right version of the SDE that you use to compile your environment. Otherwise, it will kind of break. So then when it's done with P4 Studio, it's compiled, you will have, so you take the SD Fabric. Actually, there is an implementation for Tofino, which is called Fabric DNA. So which is the code for SD Fabric on Tofino switches. So it's not the same as the other ones because they have some dependencies. When it's compiled, basically it generates 3 files. One file that is, let's say, the server to be run on the switch, the API server. Then the API description that you will use in your SDN controller so that you know what are the tables that are available on the switch. And then the actual things that has to be put, let's say the binary, it's not a binary, but that has to be put on the switch. For example, if you have a BMV2, it will be some configuration. If your target is OpenFlow, it will be the OpenFlow configuration. If the target is Tofino switch, it will be what the Tofino switch needs to put activate this. So now we are happy, we have this bundle, and we just need to, we don't have to do anything on the switch yet. You just compile it, then you have those files. This, you push them to ONOS. It's called a pipeconf in the ONOS terminology. You push it in ONOS. In this case, then it becomes like you will see it appearing in new applications that are with this particular one. So, for example, you will have org.onos fabric TNA and then you will have the version of your SDE. When this is done, we can run ONOS, and this is ONOS that will push all the things on the switches. So it's not, you don't have to do anything on the switch, you just have to do everything on ONOS, and ONOS will push. I will show you now on the ONOS should be started. We will see. Not here. I have to do a tunnel towards my, you should not ask me for password. Ah, no, it's not. I just have to make a tunnel to be able to connect to the uh, to, the switch that is okay. Normally, in your deployment, if you manage to do it, at this point, you have a node that is deployed. It has been deployed using Kubernetes on one of the three switches or somewhere in your cluster. It doesn't matter. The default username and password of Onos is Onos and rocks. So they think that Onos rocks. Nothing. And ta-da, good. So, but for the moment, so what happens is in the deployment, you will see we define also a network configuration where basically you list the switches that you have or the device that must be programmed by a NOS with the drivers that need to be used. You give the IP address, the management, everything is described in the documentation that we put on the Git. So he knows the topology, but for the moment, you see they are not up or running. You should see the link. It should be white. Nothing is there. But if we go into the applications, we see that we have different applications. So you see that we have the BMV2 driver, the barefoot drivers. We have the P4 runtime. All this, voilà, this is the important one. This is this one, what I told you before, the pipeconf, the Fabric TNA pipeconf. So while I was talking, it was compiling, and then it sends it to others. This is the application that is able to operate SD Fabric on your switch. And so now the last thing that you have to do, and it will be done, is to start Stratum on the switches. And for that, there is not much to say. Really, I launched deployment of Stratum. So, and at some point, you will see it will be deployed and everything will be discovered. So Stratum, it's relatively easy. So they provide, it's just a Docker image that they provide, and they run a container. So basically, on every single switch that you have, you just launch this container and do nothing else. You just have to do this. One particularity is you have to provide all the time a chassis config. So Stratum, as you saw before, it's a kind of a middleware between the actual software and Onos. It can be used like this. So you have to tell, so in Stratum, you will say you have different ports that correspond to the communication ports, so like network interfaces. And you have to map them to the actual interface that you have on your switch, on a physical switch. This is within the chassis config. You will see different examples of chassis config in the playbook that we have. So basically, for example, in our setup, we have 100 gigabits links, but also we have breakout cables. So breakout cable is what? On one port, 100 gigabit port, is actually split into 4 25 gigabits links. So in the description, we have them. So you specified how you want those ports, virtual ports from Stratum, to be mapped to the actual ports that you use on your switch. This is the only thing that you have to provide, but you don't specify the controller that you use or whatever. What you do is just in Onos, in the network configuration that we had, it was just written, okay, I have switch 1, you can reach it through this URI. This is the API that you can use. So for example, address 1.2.3.4/API/whatever, and using this particular driver that we see. And then eventually here we see, so it's polling, ONOS is polling, and at some point it will discover the switch. Here already discovered 2 switches, and he discovered the links because we added LLDP. So LLDP basically is trying to discover the links. And also we have a server running connected on this switch. So the server has been discovered because, it's chatty. So he's sending stuff. And at some point he discovered it. And why the third switch is not switched on? That's maybe it's broke down. I don't know. This is the actual infrastructure here. It's a physical infrastructure. So I don't know why it's not appearing. It might, or it might not. Oh, maybe we have an error. It's a demo, so we have an error. No, we have no error. Did it come? No. Let me check. Let me try to debug why. No, it's there. It's there. Okay, and as you see, it's not. It would be much faster if Stratum starts and then boom, immediately sends to the controller. Of course, that would be easier. It would be fast. But in this case, this is polling, and so Stratum took some time to be discovered by us. Actually, this is a good feature because then your switch are just normal appliance, and then they will be discovered by ONOS. You don't have to do anything. You just install Stratum, and that's it. So that's pretty handy from that. And here we see, okay, we have all the setup working. And the demo is kind of done. So of course you can go in the details, and what we see, I think I have to. The details, and it tells you, okay, I use this particular pipe conf and here are the ports and whatever. Okay. So that's what we were supposed to do together. So at least you saw it. I made the explanation. I don't know if you have any question or if it makes sense. And actually, if we have time, I would like to ask some question for actually on the deployment of these things on the actual test bed when we are targeting users. So before that, do we have any questions? Yeah, I'm a bit, I feel miserable because to make this work, actually it took quite some time, like several months. Mostly because I'm incompetent, I have to agree. So but also because of the lack of documentation. For example, we decided, so we replicated Euricom environment. Euricom environment was working on Calum, with Calum. So for them, it was kind of a black box. The people from Calum, they come, they do everything, and it works magically. But they are used to. So now I can do this like in one day, but before. So for me, it's easy now, but it was not. And so we had no information. But there is something that we didn't replicate exactly the same than people from Euricom, is that instead of using copper, we used optical fibers. So we are everything fully optical. So all we have, actually we have more than, here we see only those links, but we have much more links than that. But for the demo, it was easier to have only few links. And actually, initially, when I started to work on this chassis config and on the port mapping, I saw that, okay, in the, you have a grammar that is associated to the configuration, and it was only supposed to be copper. I was like, that's an issue because I was not able to make work. I was not able to see the links working. And I saw, okay, it's written copper. So maybe it's not, no, it's supposed to be fiber. And then actually by discussing on the Slack channel, they said, yeah, it should work automatically. Don't worry. So I was not worried anymore. No, I was still worried, but at least. But then I had to figure out maybe it's the fibers that we have or the transceivers that are not working. So instead of using the ONF, I moved to Sonic. Sonic is another operating system for switches that is proposed by Microsoft and that runs in Azure. This is what they use in Azure. And then I tested with that. We're able to see, okay, the links are working correctly. So the fiber is working. The transceivers are okay. They are compatible because you know that we take transceivers, they might not be compatible with the servers on the other side because you have compatibility issues. So all that was fixed. So at least it was not an hardware issue. Then going back, I was working and then still not working with ONF. So how come? Then at some point, the 4th of July, they published a binary version with everything compiled of ONOS. Everything is compiled. So I ran it, and by miracle, I got the topology visible. The links, everything works perfectly well, except that it's a pre-compiled thing, so I don't know what is inside. And we have an old guy at our place that is at Inria for at least 30 years, I think, before Walid. and it, yeah, it's working, but sometime the new version, or maybe they use an old version. So then I checked the version of ONOS. And actually on the website of SD Fabric, on the documentation, you see they say you need to use 2.8 at least, or 2.7, or something like this. They changed it? No, they changed it on the README? Yeah, but they say to use this one in the documentation. Yeah. And actually, the one that they use is 2.5.8. So when you use ONOS 2.5.8, it works. Very simple. So that was the trick that we had. So yes, it was measurable time. Anyway, so if you have any question when you start to the deployment, we can discuss it. Now we are pretty used to do this kind of deployment, the full deployment. And the first that we will try with Recom, because they now have some good knowledge about the upper layers, so the UPF, all the 5G functions, and they try to see how to port that on a fully open source environment. So then together in the Sophia nodes complete area, we'll be able to have a good, the full stack. So if you want to do this kind of deployments, would be normally it should be knowledgeable enough to try to figure out why it's not working. Yeah.
So the information that you declared so that we can download the image and do the test, it will stay available?
Yes, of course, yeah.
Okay. And the second one is, can someone from other than Inria connect to the Inria testbed now or not yet?
Okay. So first question is about the repository. So people that are from the project, you know that we have a private repo. Some of you already connect to it, where we have basically, it's like something moving all the time, but at least you have all the logs, all the information, and you can check it, and you have the state of the current. And here we have a public one called SOP node, where you put some kind of clean things for anybody willing to do it in SOP node or not. So that's something, and unless policies change, but normally the project of, and for the duration of the Slice project, it should be available. Now, if GitHub disappears, you put it somewhere else, of course, but those things will remain available, the public one and private. Private ones are not because we want to be closed, it's just because it's dirty and we don't want to have questions like, it's not working. But if you know people, even not from Sophia node, some from Slices that wants to get access to the repo, we give access to the repo, just because you are not mature enough in what is inside. And sometimes we might have still a password there that we, made a password in a commit or this thing. So for the second question, to connect to the soft node, so that's actually a question that discussion that we can have about the testbed. For the moment, it's not a public access, because as opposed to, for example, I mean, you go to Grid 5000 as just for using the compute resources. You just use the compute resources, you don't break anything. It's kind of the sandbox. Here, we want to be able to change the data plane by itself. So when you do your P4 program, the objective is to change the behavior of the switch. So the issue here is, how can we provide access to people such that they can do anything in the switch they want without breaking the experiments or with destroying the environment? And that's really a big question that we have. We don't know exactly how to handle this. So several of you already thought about making a test bed like this. So what are your thoughts about this? Should we provide a full bare metal access to the people, or should we kind of make a virtual version of this such that we can have several users at the same time? Because if you have bare metal, basically it's only one user at a time. So this is also why we decided to run also in a emulated environment. So people can do all their tests in the emulated environment that is a replication of Sophia node. And then when they are sure they are ready, that may take days or weeks or months, then they can push it. They cannot keep the environment for like 1 month or 2 months. So what are your thoughts? Because one is easy, the other one is hard. So the solution where you do the user takes all, it's easy. It's not very efficient, but it's easy. If we want to go to a solution for being able to run different data planes, so different P4 programs on the same switches, actually we will have to implement the solution. So slices, if we decide to do that, we'll have to put a huge effort on making this working, because it's not supposed to work like this. There is P4 brick that is kind of proposing this, but it's actually to merge applications together and to push them in the switches. In our case, that would be, okay, I'm a user. I want to run a slice with my own data plane, and a second user can come and run its own slice as well on the same infrastructure with its own data plane. And this does not exist yet for the environment. So what are your thoughts about what we should do? Yeah, can you get the... Oh, wait. But for the remote attendance.
Just a question. So wouldn't virtualizing things make performance measurements a bit unreliable? I mean, normally use this kind of infrastructure amongst others to measure performance of different things. So if you share it at the same time, I don't know how much information you can get out of it reliable.
Yeah, actually, if we virtualize, you know, that will be an issue with the, because here I show you in the very first slide, but actually we have 12 fibers at 100 gigs plus 6 fibers at 100 gigs with Recom. So that's really high speed. So virtualization is kind of an issue. And yes, for the second point, normally, but that is to be done. But you can make, you know, you can make different pipelines in P4 and make sure that they are separated and make sure that they have the performance. The problem is I don't know when you have different users, so you can split it. This has not been done yet. So this is something that has to be done. And this is, I can start to talk by experience. It's a huge effort to do that. But maybe it's an effort that is worthwhile. But are we ready to put this back? Because when it's a single user, you know, you can say, okay, you have priorities, these kind of things, and you can measure. But when it's different ones, and particularly in our case, you will want to do crazy things. It's not like we want to implement IPv7. What we want to do is layer 3 or almost layer 1 things, you know. And in this case, I don't know how we can do it. I mean, it's possible to do it, but how much effort to do it? I don't know. And particularly when it comes to wireless environment, because it will be a shared medium and
continue to be sure that I understood your answer. Do you mean that the things are much more complicated than only having problems in measuring performance because we are changing the lower layers, so we don't know what will happen exactly?
yeah, actually, the whole point, if we decided to go to these programmable devices, is to be able to run for people to really have white boxes, so they really can do from layer 1 to layer infinite, everything. So usually when we do, I don't know, even when we do the slices or these kind of things, we're at a higher level. So we can rely on the under layers. We could say, okay, I know that I have a scheduler that does it correctly and everything is clean, and that's fine. Everybody has its own little slice or work. Or I know that anyway, it does anything he wants in IP, but I have Ethernet under it, and I make my VLANs, and that's fine. I know that the traffic will not go from here to here. But then suddenly we start to have a shared memory between everything. This is basically what is done so far in P4. It's a shared memory. So everything has access, you know, everything in the same place. So how do we do to guarantee that experience from one member will not influence experience of the owner while still giving the full access to this? You know, if you have two cores, for example, it's easy. You give 1 core per person. Well, that's simple. But here we have 1 ASIC that is to be split. So probably we maybe we can change the compiler to be kind of doing the VRFs for a P4. I don't know. VRFs, it's working pretty well in the network industry. But can we do these kind of things in P4? I don't know.
And you need multiple users. Can't we say that we give half of the capacity to?
No, that's the question. So there are 2 points. So do we have multiple users? That's what you hope. If we are lucky, if everything goes well, Slices will have zillions of users all the time. So that's if we are alone, we don't care. For now, we are not having issues with resource sharing. So no, the question, the point that you say, actually, you cannot easily give half of the resource because it's one resource that you have to split. And for example, if you take resources, compute resources, you just have the OS scheduler that will schedule between your processes and so on. Here, we have to implement this separation and this resource sharing because it's not proposed yet. And to add some issue to that is you have to do it in runtime, potentially because if you do it at compilation time like P4 brick, it's easy because you take application, you merge them, and you have a new application, you push it. But you have interruption of service. So the problem is, imagine that now in Slices, someone makes an experiment, he wants to do an experiment that lasts for 1 month because he wants to see some evolution. And then someone comes and say, oh, it's Friday morning, I want to try this. Okay, we could use some kind of P4 brick evolution to say we will merge this and this together, then we restart everything. But then the experiments will break for the other one. So here we have to do it at runtime. So it's not just that we have to put the different P4 codes together, we have to be able to do that at runtime. On BMV2, it's easy. On something like a Tofino or FPGA, I'm not sure that it's that trivial. I mean, on BMV2, it's easy because you just make another instance. You start another BMV2. Anyone has experience with that already or no? And as a community, you're saying we should go to that direction. We just drop it because it's not our business. Serge.
What about ONF people? Did they
ONF people.
did they envisage this type of thing or?
Probably they envisage that I don't have view on ONF because I'm not in ONF. It's not public. There is no public things there.
Needs to be discussed. Maybe
Yeah,
not.
plus the licensing. So who plans to deploy a fully programmable test bed for users here? So we have Sophia node. I guess you want to do that as well in Paris at some point with your network. In Greece, do you plan to do that or it will remain just the upper layers?
We plan also here to create the Greek node.
Yeah, the Greek. So we have at least already three nodes with this. Plus, yeah, so you also plan. So we all kind of plan to provide this kind of infrastructure. So we have to, at some point, we have to decide how to do that because it might, I mean, it's not something that will be done in one day because currently the technology, I mean, the software technology, the hardware is there. So, but the software technology going with it does not exist. Or we decide to say, okay, you take the test bed, you need it one day, you take it for one day, like we do for R2 Lab. R2 Lab, this is what we do. You need the environment, the physical environment. You want to be sure that you don't have interferences, so you get it for this. So this is what we want. Do we want to have experiments that last only few minutes? Then it's possible. Or do we want to allow people to have experiments that last for hours or days or weeks? That might depend. That might change completely the strategy that we have to follow. I don't know if have you already thought of that or not really. Yeah, that's a good point. So the question here is, do we want to provide full access to all the layers? I think yes, because when I talk to people about slices, they are not like, wow, it's amazing, we'll have a 5G test. But no, this is not like they all said, oh, that's great, you have P4 switches, can we use them? Because we want to try to compile on real, because they do most of people, they do it with BMV2 and with simulation and say, yeah, that would be super amazing, but they don't really have access to this kind of thing. So at least several demands for having access to the lowest possible level. So being able to change the pipeline in the P4 Tofino. But maybe we don't want to provide these kind of things to people. Maybe this is not our duty. Maybe we just want to say, no, we provide 5G and this is that. And if you want to do this, no, you follow the procedure, you make a P4 program, the pipeline, it will be pushed using this, but no more. That's another solution. I don't know what I would go to providing access to layer 1 to bare metal, but this is just my opinion. This is not the opinion of the project.
Hi. So from our side, so for the Greek node, we are thinking of using actually P4 compatible smart NICs in order to arrange them in a switch-like topology. So how difficult would be to replicate this type of setup over such smart NICs?
I don't have
if you know, since
no, I don't have I don't have
experience.
experience with the NICs, but normally, so to compile, it should not be a big deal. You just need to have the compiler for the NICs, but normally if you have the Intel NICs, you have it. That should work. The issue, that's something that, P4 is just a language, like C. So you have inclusions. For example, they do in externs, they include the externs. And for example, if you look at the code of the SD fabric for BMV2 and for TNE, it's not the same. Not exactly the same. There are some differences because they use some native function of the target that they have. So first thing you will have to do is, for example, if you have SD fabric, you will have to make sure that the function, for example, they use clone3, the clone3 function in BMV2. It's native BMV2. Maybe it's not on your. So you will have to convert a bit to use, this kind of inclusion and extern that they use. So that's the first thing you have. Then you will compile, and then the good point is you generate something that normally is compatible directly with NOS. Because it will be just when you compile P4, basically it generates two files. One is kind of an API and the other. So and this will automatically be compatible with Sonos. Now, how you will integrate this NIC, how you will add it, because the NIC will run Stratum directly. Yeah, you might have issue maybe how to connect them in Stratum if it's not initially done. So maybe it's already ready for Stratum, and then you are happy and everything works well. It's still in Stratum, and then it's Stratum that takes care of everything. Otherwise, either you will have to implement something equivalent to Stratum or to update Stratum to be able to have it. Once you have this, as soon as you're able to program, let's say program the NIC via Stratum, all the rest will be fine. Modulo the little details, of course. Yes. But conceptually, it should work. Yeah, but the first thing I see is you will have most certainly need to change the P4 code. Little details here, but you have to find out why, what function you have to be changed. And then to be able to connect it to Stratum. Thank you. I think I was boring enough for today for you. So anyway, so it did not really work that well for the emulation. So the one willing to do it, don't hesitate to drop a mail to Mohamed or me. Mohamed until September because he is intern with us, and then after he will not be there. But me until sometime. So after September, only my address, but before you can be also with Mohamed. Yeah. Particularly, for example, if you want to run it on Google Cloud, so Mohamed made everything on Google Cloud. working perfectly well because you need to put some tunnels or whatever because Google Cloud gives you L3 access, not L2, but you are working in lowest level, so we need L2. So it does this kind of things. And at some point, we will publish it as well on the report. Thank you.